So my problem is the sum from k equals 1 to infinity of ln k over k to the fourth. I have to prove whether it diverges or converges and justify it. First look, using the direct comparison test or the basic comparison test, I would compare it to 1 over k to the fourth. By the p-series, 1 over k to the fourth converges. And since this is larger than 1 over k to the fourth, it doesn't help us anything, so the direct comparison test fails. So I'm going to try the integral test. I'm going to take the integral from 1 to c of ln k over k to the fourth, and I'm going to take the limit of that as c approaches infinity. I'm going to use integration by parts to integrate this using the integral test. My u is ln k, dv equals k to the negative fourth. So du equals 1 over k, v equals k to the negative 3 over negative 3. So when I looked at this, I saw that I knew that the derivative of ln k was 1 over k, and that I could get from ln k to something similar to 1 over k to the fourth. So that's why I decided to do integration by parts. So the integration by parts formula is uv minus the integral of v du. So we have ln k times k to the negative 3 over negative 3 minus the integral of k to the negative 3 over negative 3 times 1 over k. This integral can be simplified to 1 over negative 3 k to the fourth, and this can also be simplified to 1 over negative 3 k cubed. This can simplify also again. We can pull out the 1/3, so we'll have ln k over negative 3k cubed minus the integral, plus 1/3 the integral of 1 over k to the fourth dk. This changes to ln k over negative 3k cubed plus 1/3 of k to the negative 3 over negative 3. Now we're going to take this integral from the two endpoints we had above, from 1 to c. So we have ln of c over negative 3c cubed plus 1/3 1 over negative 3c cubed minus ln of 1 for negative 3 plus 1/3 times negative 1/3. Now I'm going to make these two fractions look similar to each other. So I'm going to make this 3 ln c over negative 9c cubed. I'm going to make this 1 over negative 9c cubed. So they have the same denominators. Still minus ln of 1 over negative 3 minus 1/9. We can combine these to 3 ln c plus 1 over negative 9c cubed. Still minus ln of 1 over negative 3 minus 1/9. We have to take the limit from the top. It should have been carried down to the limit as c approaches infinity. If we plug in infinity into this is infinity over infinity. So we have to L'Hopital. So 3 ln c plus 1 over negative 9c cubed. After we L'Hopital it, we get 3 over c over negative 27 c squared. This is equal to 3 over negative 27 c cubed. If we take the limit of 3 over negative 27 c cubed as c approaches infinity, the limit equals 0. This goes away now since the limit equals 0. We know that the ln of 1 is 0, so this is 0 over 3. This goes away. We just have minus a negative 1/9. So this equals 1/9. So the integral test gave us positive 1/9 as our final answer. So by the integral test, the sum of ln k over k to the 4th from k equals 1 to infinity converges because the integral test gave us a positive finite number less than 1.